We have this LC oscillation circuit, and initially it's given that capacitor was charged to a maximum voltage Vm, and then there was some switch here which is closed after that. So at t is equal to 0, the capacitor has voltage of Vm and current is of course 0. We need to find current as a function of time, and then EMF of self-inductance, basically that is LdI by dt, in the coil when the energy of capacitor is equal to the current in the coil. So previously, in the previous problem 4.95, we have seen that when you connect the capacitor and inductor, that current performs LC oscillations. And the equation is given by Q is equal to Q naught cos omega t plus phi. So just like what we did before, let's introduce voltage and current. So voltage across the capacitor we will get by writing Q is equal to CV and Q naught is equal to CVM. So we get this equation. And if we differentiate this equation, we get the value of current. Now we don't know what is phi. So for that, we are given that initially at t is equal to 0, V is equal to Vm. So at t is equal to 0, V is equal to Vm, that gives phi to be 0. So we put phi is equal to 0 here also, and we get current is equal to minus CVm omega sin omega t. And omega we have again seen in the previous problem, it is 1 by root LC. So this is the current as a function of time. Now second part, we need EMF of self-conductance. So what he wants is EMF across the inductor, but that is same as EMF across the capacitor. And we know EMF across the capacitor is V. Now they have given energy of the capacitor is equal to the current. So that means energy of the capacitor is half the total energy, because half of the energy is gone to the inductor. So total energy is equal to twice of energy stored in the capacitor. So from here we get the value of V to be Vm by root 2. And now EMF across coil is LdI by dt, which is EMF across capacitor, which we just calculated, that is Vm by root 2. Alright.